Hello everyone, this is DSA Zindabad. Today we are going to solve the first question of Arsh Goyal DSA sheet. The question is find the duplicate number. Let's see what does the question says. The question is given an array of integer nums containing n plus 1 integers where each integer is in the range 1 to n inclusive and there is only one repeated number in the nums array and we need to return this repeated number. You must solve the problem without modifying the array nums and uses only constant extra space. So what is our main goal? Our main goal is to find the repeated number or the duplicate number by using big O of one space complexity, right? Now let's look at the example. We are given the nums array as 1, 3, 4, 2, 2. As we can see directly from the given array, 2 is the repeated number, so we are going to return 2 as the answer. And second example says nums array is 3, 1, 3, 4, 2, and 3 is the repeated number over there, so we are going to return 3 as our answer. So now let's jump into the approach, how we are going to solve this problem. First of all, let's talk about the brute force. Let's see what does the brute force approach says. Brute force approach says, first of all, you need to sort the array, then traverse over the array linearly to find out whether two consecutive elements are equal or not. If they are equal, then you need to return that this is our duplicate, right? Now let's write the pseudocode for the same. Here's the pseudocode. Like, first of all, let's take the example 1, 3, 4, 2, 2. So after sorting, the array will become 1, 2, 2, 3, 4, right? And after this, we need to traverse over this array linearly and find out whether two consecutive elements are equal or not. If they are equal, then this will be our duplicate number, right? What we can do, we can run a for loop from I equal to 0 till n minus 1 and check if nums of I is equal to nums of I plus 1, right? If this condition holds true, then we need to return nums of I, right? And we can also run our for loop from I equal to 1 till n and check whether nums of I minus 1 is equal to nums of I. If this condition holds true, then we need to return, right? Now let's, both of this loop will require big O of n time complexity, and for sorting we require big O of n log n, right? Now let's do a dragon for this example. We are going to use this loop for dragon, right? 1, 2, 2, 3, 4. This is how the array will look like after sorting. After sorting, right? Now, initially our pointer will be pointing to the first element and I plus 1 will be pointing to 2. Now we are going to check whether 1 is equal to 2. No, 1 is not equal to 2. Then we need to increment our pointer. Now, as you can see, 2 is equal to 2. Then 2 is our duplicate number, right? So now let's discuss the time complexity and space complexity for this approach. Time complexity would be big O of n log n for sorting the array and big O of n for traversing over the sorted array, and this will ultimately become big O of n log n. And space complexity would be big O of 1 since we are not using any extra space. No extra space, right? Now let's discuss another approach for solving this problem. This is also like kind of brute force approach, and this is hashing. For hashing, we are going to use hash map, and hash map store elements in the form of key value pair 1, 3, 4, 2, 2. This is our example, right? Now let's say this is our hash map. This will be something like map, int, comma, int, and map, right? This will be our number, and this will be our frequency, like frequency of each and every element in the num set, right? Now, first of all, we are going to check whether this is present in our hash map or not. No, since it is not present in the hash map, its frequency will be 1. Now we are going to do the same thing for other elements also. Since 3 is also not there in the hash map, its frequency will also be 1. Same goes for 4, and same goes for this too. Now, when we move to this 2, which is present at the index 4, now this element is already there in our hash map, so its frequency will going to change. Now it will become 2. This is our hash map after inserting all the elements, right? Now, after this, we need to traverse over the map, traverse over map to find out whether there is an element or not whose frequency is greater than 1. Right? We need to check if there is any element whose frequency is greater than 1. If this condition holds true, then we are going to return that repeatedly, right? Now this will be something like this, like if I dot second, what does I dot second represent here? It represent frequency is greater than 1, then we need to return I dot first. What does I dot first represent? It represent number. Since, as we can see directly from the hash map, 2 is the repeated number. Since its frequency is greater than 2, so we are going to return 2 as our answer. I hope this approach is also clear to all of you guys. Now let's discuss the time and space complexity for this problem. Time complexity would be big of n for storing elements in the map, and big of n for iterating over the map, and ultimately this will become big of n. Now for space complexity, since we are using extra space over there, like by using hash map, we are storing each and every element, right? So its space complexity would be big of n. This is for storing, right? Instead of hash map, what we can do, we can also use set data structure. Set data structure works in a much similar way, like it stores unique elements, right? When we are using set data structure, we are going to check whether this element is present in our set or not. If the element is present, then we need to return like this is our duplicate number, right? And time and space complexity would be same as that of the hash map, right? Now let's discuss the optimize approach. Optimized approach, right? So before moving to the optimized approach, we are going to discuss one method of linked list, like you can say one approach to detect cycle in a linked list, which is slow and fast pointer approach. Guys, this is not the direct intuition. Now let's see what does slow and fast pointer approach says. It says when we are provided with a linked list, and let's say there is a cycle in our linked list. This is used to detect cycle. To detect cycle in a linked list, right? Now after and we have two pointers, slow and fast. We slow pointer will move by one step, and fast pointer will move by 2 steps. Initially, both slow and fast pointer will be pointing to the initial node, which is one over there. Now we need to iterate over this linked list by using the slow and fast pointer. Slow will be incremented by 1 step, and fast pointer will be incremented by 2 steps, and slow again, same thing. Now, whenever there is a collision, this means there is a cycle and we need to break. Remember guys, whenever there is a collision between slow and fast pointer, there is going to be a cycle in our linked list, right? So what we need to keep in our mind, whenever there is a collision, this means there is a cycle and we need to move slow and fast pointer by 1 and 2 steps respectively. And this approach is used to detect cycle. We need to keep these three things in our mind. Now let's see how this approach works for our problem. Let's take this example, which is 1, 3, 4, 2, 2, right? And this is the index 0, 1, 2, 3, 4, right? Now remember guys, we are not creating any linked list, no linked list. We are just using the concept of slow and fast pointer approach in our problem, right? No linked list. Now we are at the index 0, and at the index 0 we have this element 1. Now after this we are now we will see the element at the index 1, which is 3 over there. Now at the index 3 we have 2. Now at the index 2 we have 4. Now at the index 4 we have again. So now at the index 2 we have 4. Now at the index 4 we have again 2. So this thing is repeated. Right? This thing. Now again at the index 2 we have, so there is some cycle over there. Right. Now let's look at the visual representation. This is just the visual representation. No linked list is present there in the R nums array, right? First of all, 1 is over there and 3 is over there. Now after 3, this will be pointing to 2. After 4, now this will again point to this thing. 2 will again point to 4 and 4 will again point to 2. 4 will again point to 2, 2 will again point to 4. There is a cycle. All right. Now let's do a dry run for this. What we need to keep in our mind, slow and fast pointer. Slow by 1 step, fast pointer by 2 step. Initially, both slow and fast pointer will be pointing to the first element, which is present there at the index 0 in the nums array. This is not the linked list, just visual representation of our nums array, right? Now we'll increment slow by 1 step and fast pointer by 2 step. Now again, fast pointer. Now, as we discuss in slow and fast pointer approach, whenever there is a collision, this means there is a cycle, right? As we can directly see from the nums array, there is a cycle present in our nums array, right? Whenever there is a cycle, this means there is a duplicate number. Remember guys, whenever there is a collision, there is a cycle. Whenever there is a cycle, there is a duplicate number, right? Now you guys be like, since we are using the concept of slow and fast pointer approach, now after dry run, we find that slow and fast pointer collided at second, which is our duplicate number. So this is going to be our answer. Yeah, this is our answer, but this approach might not work for all the test cases, right? Let me provide you with a different example. The example is 2, 5, 9, 6, 9, 3, 8, 9, 7, 1, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's do the same thing as we did above. First of all, we are at the index 0 and the element is present, is there at 2. Now we'll directly move to the element which is present over there at the index 2. There we have 9. Now we'll directly go to the index 9 and now we'll directly go to the at the index 1. We have 5, right? Now at the index 5, we have 3. Now at the index 3, we have 6. Now at the index 6, we have 8. Now at the index 8, we have 7. Now at the index 7, we have 9. Now at the index, remember guys, now at the index 9, we have 1. Now at the index 1, we have 5. So this is going to repeat. So this means there is a cycle present over there. Like after this thing is going to repeat, right? Let me just draw this in a much better way, like the visual representation, right? First of all, we have 2, then we have 9, then we have 1, then we have 5, then we have 3, then we have 6. After 6, we have 8. After 8, we have 7. After 7, we have 9. After 9, we have 1. Then again, so. So there is a cycle, right? As we studied above, whenever there is a cycle, this means there is a duplicate, right? Now let's do a dragon. Initially, slow and fast pointer will be there, slow by 1 step, fast pointer by 2 step, right? Now, slow pointer will be pointing to 9 and fast pointer will be pointing to 1. Slow pointer will be pointing to 1, fast pointer will be pointing to 3. Slow pointer will be pointing to 5, fast pointer will be pointing to 8. Slow pointer will be pointing to 3, fast pointer will be pointing to 9. Slow pointer will be pointing to 6, fast pointer will be pointing to 5. Slow pointer will be pointing to 8. Fast pointer will be pointing to 6. Slow pointer will be pointing to 7. And fast pointer will also be pointing to 7. Now there is a collision. Now, according to slow and fast pointer approach, we should stop whenever there is a collision between slow and fast pointer approach, right? Slow and fast pointers, right? Now, slow and fast pointer are pointing to the element 7. Is 7 is our duplicate number? No, this is not our duplicate number. Our duplicate number is 9. So we need to return 9 as our answer. As you can clearly see, the approach of slow and fast pointer is helpful only for detecting a cycle in our nums array. It does not guarantee the exact location of the duplicate number. So to find the exact location, so to find exact location, we need to modify our approach a little bit. All right. So how we are going to modify the approach? Like after first collision, will directly move fast pointer to the initial start of the nums array, which is num0, and slow pointer will stay same as previously there it was, and now will again run a loop like until they collided for the second time, run loop until second collision. But this time we need to keep this thing in our mind. We are going to iterate over the nums array with the help of slow and fast pointer, right? But this time they both are going to move by 1 step, right? Now let's look at the diagram. And then make this thing again. 2, 9, 1, 5, 3, 6, 8, 7. After 7 we have 9. And slow and fast pointer are pointing to 7, right? Now, as we discussed above, after their first collision, fast pointer will be pointing to nums of 0, which is 2 over there. And slope pointer will stay the same. Now we need to iterate over our nums array with the help of slow and fast pointers by one step. Now this will point to 9. Slow pointer will also be pointing to 9. Now we need to return this. Now, whenever there is a second collision, slow and fast pointer will be pointing to the duplicate node, as we can see, right? So this is going to be our approach for the problem, right? I hope this approach is clear to all of you guys. Now let's try to code this thing up. Initially, we have two pointer, slow and fast, and they are pointing to the start of the num set, which is nums of 0. Now we need to run a loop. Nums of fast pointer will be incremented by 2 steps, and slow pointer will be incremented by only 1 step until they collided for the first step. Right? This is for the first collision. Now after first collision, fast pointer will be pointing to the start of the array, which is nums of 0. Now we again need to iterate over the array until they collided for the second time. Now nums of slow by 1 step, both slow and fast pointer will be by 1 step, right? Now at the end, we need to return the pointer. Let's try to run this code. This works perfectly fine for this example 13422. Now let's try to change this example, which is 2, 5, 9, 6, 9, 3, 8, 9, 7, and 1. Right? 9 will be our duplicate number in this example. This is returning 9 as the answer. Now let's try to see this thing. This runs perfectly fine. Now let's discuss the time and space complexity for the scene. As we are creating two pointer over there, so it will require big of one time, and uh, we are iterating over the nums array until there is a first collision, right? So it will require big of n time, and this loop will also require big of n time. So time complexity would be big of n plus big of n, which will equivalent to big of n, and space complexity is big of 1 since we are not using any extra space, no extra space. Thank you so much, everyone, for viewing the video till the end. Please like, share, and subscribe. Thank you so much.